This is the solution to example 6a from the 6.5 notes, and we're going to graph a transformed cotangent function. Y equals 1/2 cotangent x over 3. We're going to begin by finding out where the vertical asymptotes are, and we're going to think about the parent function of cotangent. For cotangent, the vertical asymptotes occur at x equals 0 and x equals pi, but for this problem, instead of x, our input is x over 3. So we want to know when is x over 3 equal to 0 and when is x over 3 equal to pi. If we solve these two small equations, we'll get that occurs when x equals 0. Multiplying the second equation both sides by 3, we'll get x equals 3 pi. Alternatively, we could think about the vertical asymptotes occurring at 0 and pi, and then if we replace x with x over 3, this is the same thing as a horizontal stretch by a factor of 3, which means that the vertical asymptotes are going to be stretched out by a factor of 3, so they're going to be at 0 and 3 pi. Next thing we want to know for our graph is the period. So we'll do two methods to determine the period. One method is that the period for the parent function is pi, so the period on the transform function is pi over b. For this problem, b is equal to 1/3, so pi divided by 1/3 is pi, flip the denominator and multiply, so pi over 1 times 3 over 1 is going to be 3 pi. Alternatively, we can think about the period as the distance between two vertical asymptotes. The distance between 0 and 3 pi is 3 pi. So our period is 3 pi, and the period is going to help us determine the intervals for our x scale. So for our x scale, we're going to have key points every 1/4 period. And so that's going to be every 1/4 times 3 pi, which is 3 pi over 4. So when setting our x-axis, we're going to want to use 3 pi over 4 as our scale. That will help us. And then we're going to transform 3 points. And you'll notice up at the top it says graph 2 periods and 3 points per cycle. So on the parent function of cotangent, the 3 key points that we're working with are pi over 4, 1, pi over 2, 0, and 3 pi over 4, -1. And then we are going to apply the transformations that we see to x and y to get our transform points. So what's happening to x in this graph is we have a horizontal stretch by 3. So that means we're going to multiply x values by 3. And what's happening to y values, got a different color here. What's happening to y values is y values here, because we have the 1/2, this is a vertical shrink by a factor of 1/2. So we're going to multiply y values times 1/2. So we're going to transform each of these 3 points using the analysis that we did. So x value is going to be multiplied by 3, so pi over 4 is going to become 3 pi over 4, and then when we transform the y point down here, it's going to become 3 pi over 4, 1/2. Pi over 2, 0, we're going to multiply x by 3, so that's going to become 3 pi over 2, 0, and then we're going to multiply y by 1/2, so it's still going to be 3 pi over 2, 0, because 0 times 1/2 is 0. And then we're going to multiply 3 pi over 4 by 3. That's going to give us 9 pi over 4, -1 for the third point. And then when we multiply the y value by 1/2, we're going to have 9 pi over 4, -1/2. So these are going to be the 3 points in one cycle. To sketch the next period, just shift everything over 3 pi. So the next cycle, shift all points over by 1 period, which in this case is 3 pi. Okay, so let's go ahead and sketch this graph. We have all the analysis done. I'm going to set my x scale based on this interval of 3 pi over 4. So I'm going to let two lines here be 3 pi over 4. So 3 pi over 4, two lines over more would be 6 pi over 4, but I'm going to simplify that to 3 pi over 2. 3 pi over 4 more, so 6 pi over 4 is going to give me 9 pi over 4. 3 more pi over 4 is going to give me 12 pi over 4, but I'm going to write that as 3 pi. I'm going to add another 3 pi over 4, so I was at 12 pi over 4, and then I'm going to be at 15 pi over 4, and another 3 pi over 4 is going to be 18 pi over 4, which I'm going to simplify to 9 pi over 2, and then I'll put the same values in the negative direction. So negative 3 pi over 4, 2 more lines, negative 3 pi over 2, 2 more lines, negative 9 pi over 4, and then negative 3 pi. And I'm going to put on the vertical asymptotes that we found. We said those occur at x equals 0 and x equals 3 pi. And then we'll have vertical asymptotes every 3 pi at intervals of 3 pi. So I can put another vertical asymptote at x equals negative 3 pi. And that's going to be enough for 2 cycles on our graph. Now let's plot a few points. So I'm going to plot these key points that we found. So that's, here they are, 3 pi over 4, 1/2. Oh, I need to set the y scale. I'll let 2 units be 1, 2 squares be 1 unit. So that'll be 1, -1, -2. Always set scales on both axes. And now let's sketch our graph. So 3 pi over 4, 1/2. It's right there. 3 pi over 2, 0. 9 pi over 4, -1/2, and then sketch a nice smooth curve in the shape of cotangent approaching the vertical asymptotes, and then we can repeat this over in the next period. So I'm going to repeat this over here. So negative 3 pi over 2, 0, negative 9 pi over 4, 1/2, and negative 3 pi over 4, -1/2, and we'll sketch that here. And then I can sketch half a period in this last cycle. So we'd have 9 pi over 2, 0, and 15 pi over 4, 1/2. And that's our graph.